So this subject will give you maximum exposure towards the fundamentals of those things. The information theory starts right from the basics of communication. So that I would like to tell you. So if we are strong in the basics of communication, that is the subject called analog communication, digital communication, we can easily understand this information theory also. So the major prerequisite for that is you need to have a good idea over the subject of communication. So I think, is everybody able to see this slide? Can anyone turn on your mic and tell me whether the slide is
Sir,
visible?
it's visible.
Uh,
It's
can
visible, sir.
can you, yeah, can you read out the first line, please?
A professional like you want information theory on coding. Unit 1, Part 3, Source Coding and Entropy. With Sri
Okay, very good.
Dinesh Kumar.
Very good. Okay. From this, I understood that you're able to see my presentation.
Okay, okay.
So, the source coding and entropy is your first unit number one's name. So, rather than starting directly with the class, I will give you an information of how this communication has started. Okay. So, I think everyone are familiar with this block diagram. I think so, right? So, in a communication system, we'll be having three major parts. First part is your source, which would be at your transmitter. The second part would be your receiver, which would be at your destination. So, what happens at the transmitter? What happens at the receiver? Is what I had given you as a block diagram, a simplest form of block diagram. Okay, these are the two aspects. One is your source, another one is your destination. So, what is the third one, which is present apart from the specified is your channel? The source, just a minute, somebody is coming in the line, I'll check and I'll admit them. Chandu from outside, okay, I'll admit them. Is it now visible? Chandu, who came late to the class. Chandu, is it visible? Chandu is there? Okay. Pawan, can you see this? Can you see
Yes,
the
sir.
presentation?
Yes, sir.
Okay, okay. Because somebody came in between late to the class. So for admitting
Okay,
that, I need to go back and come back. So such
okay,
that
okay,
he
sir.
doesn't get miss the classes. Okay, so
No,
that's
sir,
what I'm
it's
checking
visible,
whether the
sir.
slide is visible. Visible, okay. So
Okay.
as said already, a communication will have three parts. One is your source, another one is your destination. So the third part is your channel. So where does this channel lies? So source is an device, destination is a device. So interconnecting these two devices, we have a intermediate system in between the source and your destination, which you call as a channel. Okay, understood this point? So here, if you see the green color boxes or blocks represents your devices that are used as source or destination and source both together. That means we need to be familiar with three different terms. One is simplex communication, half duplex communication, and full duplex communication. Simplex communication is that one way of transmission. Only transmission will occur, or either reception only will occur. So the examples are your paging systems. So where we can send only texts or SMS from the transmitter to the corresponding receivers. So those are the simplex form of communication. So when we say half duplex systems, half duplex are the best examples are your walkie-talkies, where it only transmission or reception can be done one at a time. At instant period of time, either transmission or reception can be done. So this is half duplex. So whereas coming to full duplex, we can do transmission and reception at a time. I think nowadays all the systems are being configured that we are using. Even this video lecture class is being dealt with the full duplex modes. So considering all these things, this block diagram will represent this green color blocks represent your two devices. Okay, considering maximum full duplex. So information source is a transmitter, destination is your receiver. Okay, green color. So those are the devices. So now in between these two devices we have a channel in between, so which we call it as communication channel. So for example, if I am a source, I am sitting at Kanjipuram, you are a destination, you are sitting at Hyderabad or Guntur or Tirupati or Nellore or Puttur or whatever might be, wherever you are. So in between you and me there is a huge gap. The gap which is in between you and me is huge. So I am communicating with you with the help of a channel. So my channel is internet. Internet lays in between, either in the form of wired or wireless. If you're using if you're using landlines for internet, so that represents an example for wired system. If we are using mobile phones or Wi-Fi's or hotspots, those represents for wireless. I think everyone are familiar with the wired channels and wireless channels. Examples. So what happens in between the communication channel and the source, or the communication channel and the destination, is that we'll be having some coding techniques which I had given you as a coding in brown color block. So the brown color block represents your coding or decoding. So here where the machine in the form of either mobiles, laptops, computers, PCs, or any transmitting devices will be having a coding structure. For example, if I have a message to say to you, I am saying that today is what do you call Gokulashtami. This is my message. That message will be converted to into its corresponding symbols or signals in any format. For example, I give an example of English. Message is this: today is Gokulashtami or today is Krishna Jayanti that I give. That has to reach to you. So it takes some forms of codings. We'll be doing some coding on that. Convert those corresponding audio or text or video or data signal into some symbols, either in the form of zeros and ones. We have some appropriate algorithms for that for converting coding. Okay, so they are being encoded. As you are familiar with encoding scheme in digital system design, so encoder, use of an appropriate encoder. A decoder, what happens is that the signals that are being obtained in zeros and ones, which are being transmitted at your coder, will be converted back to its original form. For example, if I'm using text, or if I'm using audio, if I'm using video, or if I'm using any symbols or data text, the corresponding uh, zeros and ones of binary form should be converted to its original formation. Fine. So here where this decoder plays a major role. So the inverse of your coder is your decoder. I think most probably everyone would agree and would have studied also, or would have learned better than me in the case of decoder. Okay. So then the original form which I had transmitted to you is today is Krishna Jayanti or today is Gokulashtami, that I say will be retrieved to you at your receiver path. So if you are having the appropriate information, for example, in the form of audio, you will get in the form of audio. If your information is in the form of video, you'll get in the form of video. If the information in the form of text, you'll get in the form of text. Okay. So this is our normal communication channel is ideally. Okay. So what happens in this is that when we go for realistically, some form of disturbances or noises or distortions occurs in the channel, which adds up with the existing message signals. So we have some message signals, some information. So along with that, noises gets added as the distance between the transmitter and receiver increases, or as the distance between source and destination increases, we get added up with noises. Okay. So this noises has to be eliminated or minimized as much as possible. So this is our aim or target for each and every communication engineer is. Okay, so any doubts in this block diagram? So if you say me to proceed, I'll proceed. Because this block diagram lies as an important in most of the EC engineers' life, especially communication engineer. So any doubts? Anybody? I'll ask from the bottom. Shrikala, any doubts?
No, sir.
Yeah, fine. Got some
Sir, sorry for
distractions.
interrupting, sir.
Ah, yes. Tell me, Lakshman.
Sir, once check the PDF list and the students, sir. Somewhat confusing, sir.
PDF means which one? Diagram?
No, sir. That our class list is present now, sir.
I'm showing you. Can you able to see the screen? I'm
Yeah,
showing
sir.
you who
That's
all are
okay,
being
sir.
added.
Once check,
Uh,
sir. We are having 19 members now, sir.
in current meeting or in group, WhatsApp group?
In not in group, sir. You have sent a link, no, sir. You have sent a document, no, sir. 19 members.
Yes, yes.
Hmm.
In the
In
total
that
strength
group,
is
somewhat disturbance is there, sir. Means some names are not available here, sir. Confusion, sir, somewhat. Once check in that PDF and here present name list, sir. Hello.
సార్ లెఫ్ట్ అయిపోయారా?
నేను కూడా అదే చూస్తున్నా, సార్ వెళ్ళిపోయారు.
ఆ,
ప్రణీత్ గడు అందులోనే ఉండిపోతాడంట. ప్రణీత్ గడు ఉమాపతి సార్ క్లాస్ లో జాయిన్ అయిపోయాడు.
రేయ్
ఓహో.
హలో హలో ఆగు ఆగు నిమిషం ఆగు. రేయ్
ఆ,
హలో
ఆ,
అరే ఎక్కువ మాట్లాడుకో, మధ్యలో వస్తే ఏం
ఇప్పుడు
చేయలేదు.
హలో
హలో, కంగారు పడకరా,
హలో
వంశీగడు వస్తాడు నీకు తోడు.
ఉదయం నాకు పని ఉందిరా, మ్యాచ్ ఉంది పోతాను, తొందర చెప్పు.
సరేనా.
అటెండెన్స్ వద్దా?
దీంట్లో అంటే ఇది ఆన్లైన్ లోనే ఉంటుందా? నీకు పడుతుందా లేదో చెప్పు ఇప్పుడు అటెండెన్స్.
ఏమో నాకు తెలియదు అది.
నీ గబ్బురాయాలా.
సార్ వెళ్ళిపోయారేంట్రా?
హలో
ఉమ్,
ఇది కరెక్టే కదా?
ఇది కరెక్టేరా, నువ్వు కరెక్ట్ క్లాస్ కి వచ్చావు.
ఆ,
లక్ష్మణ్ సార్
Yeah, since I'll call out each and everybody's name, kindly give me attendance for this session. Yeah, Sai Vamsi.
ఓకే సార్.
Yes, sir.
Yeah, right. Sri Harsha. C016 Sri Harsha.
Yes sir, he's there sir, it is showing sir.
He's no same to give attendance such that I can mark it parallelly.
Okay sir.
Okay, I'll mark it also. Those who didn't give me attendance. Sri Vishnu. Yes, give me your attendance. Who came just now to the class? V2 boy, turn on your mic and say your name.
Akash, sir.
Wait a minute. Akash number?
11189C152.
152.
Yes, sir.
So what is your elective? Check your elective. What is your elective? Akash, check your elective. What subject you gave? Your name is not with me.
Okay.
Yeah. Then Sri Harsha is not available. Sri Vishnu.
Ryan sir. Ryan sir.
Okay. Sri Harsha is also present.
Yes sir, present.
No,
Sir,
Sri
that
Harsha
is Sriharsha only.
present. Okay. Venkata Sivasai.
Present, sir.
Purna Venkata. Okay. Sai
Yes,
Shrikar.
sir.
Present, sir.
Pavan Chandra. Pavan Chandra.
Present, sir.
Okay. Naresh Reddy.
Present, sir.
Anuja.
Yes, sir.
Pavan Kalyan Reddy. Pavan Kalyan Reddy. Not there. Lakshman.
Sir,
Okay. Praneeth.
sir, Pranit want to join another elective, sir. Antenna and propagation. He said right now, sir.
No, that is not possible. The list is being generated and given.
Yes, sir. But he's in
It is not
Ganpati
possible.
sir's
It
class,
is
sir.
not. No, he won't be given attendance.
Okay, sir.
Since the information is given by the corresponding class in charge and it is being recorded and sent to all, no change of elective. Inform to Praneeth.
Okay, sir. I'll tell him, sir.
Yeah. So Harshita.
Present, sir.
Okay, very good. Surya, Chandana. Manaswini,
Present, sir.
Kishore.
Yes, sir. Yes, sir.
Okay, Vamsi. Vamsi. Reddy Kumar. Reddy Kumar. Sri Kala.
Present, sir.
Okay. Sai Srija.
Present, sir.
Okay. So the names which is being displayed other than this, if you are available in this meeting, kindly leave this meeting. Check with your class in charge which elective you had chosen and given. Okay, only these persons are meant for information theory and coding subject elective. So this is final. No change of elective. And the absentees for this session. Yeah, someone has joined just now. May I know who it is? VLV, your register number name, please. VLV. Who joined late to the class? VLV? Yes, left the class. Okay, C041 is absent. C061. Do we have any person, Venkatesh, in our class? Venkatesh Mandavalli. No, we don't have. We don't have Venkatesh in the class, so I'll reject it. C041. Absentees are C041, C061, and C132.
132 in the challenge.
130?
Two.
Who else is,
Came
else
and
is
left
there?
no one. Reddy Kumar.
Number?
132. C132.
Your name, please.
My name Vansi, sir.
Okay, turn on your.
Came and left.
You're 132.
I'm 127, sir. 132
Yeah,
came
you are
and left.
present, man. Vamsi is- Who came and left?
132 came and left, sir.
Why he left? He should attend the class, no?
Yes, sir. I'm sorry.
He should attend the class, right? One 32. Okay. Okay, if he comes in another 5 or 6 minutes, we'll admit him and I'll give attendance for him. So absentees are 41 and 61. If other than these people are available in this meeting, kindly leave and check with your class in charge, which is your elective, and attend that class appropriately. No change of elective. Okay. Okay, shall I proceed then? Lakshman?
Yes, sir.
Okay. Is the screen visible?
Yes, sir.
Okay.
Sir, 132 present, sir.
130? 2 present.
2.
He came into
Yes,
the
sir.
class. Okay, if he comes in.
Now I am only talking, sir.
Reddy Kumar.
Yes, sir. Yes,
Is it
sir.
Reddy? Okay, very good. Welcome to the
Yes,
class.
sir.
Okay.
Thank you, sir.
Okay. So in the next slide, I had given you some of the examples of communications. So can you able to identify me what is the first what do you call first picture that you are able to see? First picture.
Sir, we are unable to see the slide, sir. Now it's just showing your profile.
Showing my profile. Okay, I'll start from the beginning. Now what it is showing? You are able to see the slide? Reddy Kumar, you are able to
Yes,
see
sir.
the slides?
Yes, sir. Yes,
Everyone?
sir. Now we can see, sir.
Now it is visible.
Yes, sir.
Yes, sir.
Okay.
Yes,
Okay,
sir.
Yes,
very
sir.
good. Okay, communication channels. Okay, so can you say me these 6 different devices that you're able to see? Anybody can answer, those who are familiar. First
So
one,
the first one is looking like a router.
router, very good.
The second picture is mobile phone, cellular phone.
Yeah, okay,
And the third one is satellite image. Fourth one is a floppy disk.
yeah,
Fifth one is a CD-ROM, CD drive.
yeah,
And the last one is looking like some sort
okay,
of cable, optical fiber or something. Cable,
yeah,
communication cable.
yeah. It is a coaxial type cable. As
Coaxial
you
cable.
said, all the 6 answers are correct.
Thank you, sir.
Yeah, it's a type of coaxial cable. Either it is for interconnecting the channel and the devices. So all these things can be interconnected to each other also with the available parts. Okay, so this satellite, for example, if I have a cell phone with me, I assume that we have a transmitter and receiver as a cell phone. So that transmitter or receiver acting as a cell phone transmits our signals in the form of messages, either through antennas, either through your Wi-Fi ports which is being available, or your routers, to the space where satellite is present. And from the satellite, through the same form, in reverse, it reaches the receivers. So these are some of the examples for that. So coming to uh, the information theory. So the information theory is being evolved from digital communication, and who has been the backbone of this digital communication is Sir Claude Elwood Shannon. So he is the root for our modern digital communication system. So
Small doubt, sir.
his paper, yes, yes, please, yes, you can proceed. I am unable to get your queries. Is it audible?
He left the meeting, sir.
Yeah. Who? Reddy Kumara?
No, sir. No, sir. Someone VLV.
No, sir.
By
VLV,
mistake,
what attendance he gave?
Not
by
me.
mistake, he came into the class and he left, sir.
Okay, he's other than our class, right?
Yes, sir.
Okay, so I'll make a note. So he might not be allowed for next class. Okay, shall I proceed?
Yes, sir.
Okay. So the father of digital communication is Sir Claude Elwood Shannon. In the year 1948, he had wrote a paper, a mathematical theory of communication, which made him as the father of digital communication. So his role in this subject is vast, and due to his contribution, the evolution of communication reached another level. Okay, so the figure that you are able to see is Mr. Shannon's. So then move on to the next slide. So what did he contribute for communication, and what is his evolution towards this? So what is his contribution according to communication is that the fundamental problem of communication is that reproduction of the same message which was being transmitted at the transmitter to be retrieved at receiver is a major task. So this problem he has addressed. The problem of communication is that at transmitter we have message which is being transmitted, at receiver we have message being received. So in between these two we have a channel. So this channel creates or gets added up with much more noises along with your message. So reproducing the same message at a particular point exactly or approximately is a major task. So he has given an appropriate study over that in his mathematical theory on communication. Okay, the meaning is that frequently the messages will have some meanings which is what the message is to be conveyed from one point to another point. So whatever is irrelevant to the information is called as noise. So that he has addressed. Okay. Which we call it as Shannon's definition of communication. You can see the fundamental problem of communication is that reproduction at one point, either exactly or approximately a message selected at another point. So communication occurs from one point to another point. So reproducing it from that point to this point is a major task. So what did Shannon want to do? He wanted to find a appropriate and optimal and maximum possible rate of a communication. So if, for example, if I am sending 100 symbols of information, at receiver I should receive 100 symbols of information. So that is what a maximal possible rate is. And the channel which we are using for this should be reliable. Okay, the best example for reliable is that during our meeting I relied on somebody called VL_02, assuming that he is a part of our class member, but he has broken the reliability that he is not our class at all. So this is just a good example of how reliable stands. So the channel that we rely on should be good. It should withstand our characteristics, fine, so such that we get maximum possible rate. Okay, so you can see the same block diagram which I had shown you in previous information, destination, and we have in between information or the source and the destination as channel, and the flow of signals or the flow of information in the arrow mark. Yes.
Is this antenna and
please.
propagation class, sir?
Your name, please.
VLV, sir.
VLV. What is your full name?
VLV, sir.
No, say your full name.
Prasad, sir.
Your register number.
This is this
register number?
propagation class, sir?
You say me your register number, please.
Hello.
You say your register number, please.
Net problem, sir.
Say your register number. I think you are all able to see this name list, right? Despite of that, he is asking whether it is antenna class. He is unable to say his name properly and his register number properly. So I am showing you the name list. Only there is no person such having initial V at all, and no name with Prasad also. So I can skip these queries. Sure. Can I skip these queries and shall we go for class Kishore? I think Kishore is there. Kishore?
Yes, sir. Yes, sir.
Can
yes, sir. We may proceed, sir.
Can I skip the queries?
Yes, sir. Sure, sir.
Yeah.
Yes, sir. Sure, sir.
I think somebody else. Okay. Is presentation available, Kishore? You are able to see presentation?
Yes, sir. Yes, sir. Clearly visible, sir. Yes, sir.
Yeah, right. You are able to see the two green blocks, two brown color boxes, blocks.
Yes, sir. Yes, sir. Yeah, clearly visible, sir.
Okay, right. So, and best example of this Shannon's digital communication is the usage of ASDL, ADSL at our home. We'll be using ADSL boxes. So the ADSL box is what I'll show you now. So the first one, somebody has said this as a router. If you're having a landline telephone, okay. So this first Wi-Fi router is your ADSL thing. It is a box which connects them. So now in the next slide, I'm going to show you the Shannon's vision. How this Shannon's vision came into existence. So in the same paper, he had built a rich theory to the problem of reliable communication. Okay, the term reliable communication is being converted into information theory, or the name called Shannon theory, in order to honor him. His contribution was that much such that today's internet or today's worldwide information that we are receiving, right from America to India or anywhere, worldwide communication is being established only due to his vision. His vision was to provide efficient communication between two different points. Being data as our information, or the information which is to be conveyed from one point to another point is taken as a data in whole, concising all your video, audio, text, speech, everything will be converted into its corresponding data, either in some converting all the informations into corresponding data. So this data would be source encoded by using some source coding techniques. Then we'll be sending it to channel encoding techniques, then to the wired or wireless channel, and then that will be sent it to its inverse of the channel encoding or decoding, and the inverse of source encoding, which you call as source decoding, and to the corresponding another user, or in the its corresponding format, either in the form of audio, video, or text or speech, whatever might be is information. So whatever information is being generated, it should be replicated at another point. This was his vision. Examples of the same block I'm showing you with an relevant examples. So somebody has said the diagram correctly, disk storage. You can see that. So what do we use in the form of a data? Either any audio, video, file, text, speech, anything can be taken as your data. And instead of your source encoding, the examples of the source encoding, I'm using zip, rar, or anything. And I'm going to use a channel coding as CRC, cyclic redundancy check. Okay, then I'm going to pass it through a channel, and in the decoding section I have verify, CRC, cyclic redundancy check, and an unzip format, and to its corresponding user. Example of disk storage. So what happens in each and everything, I'm going to explain you. What happens in the zip, what happens in the CRC, what happens in the unzip, and what happens in the verify CRC. What happens in the zip is that in zip, whatever the data that is being accumulated gets concised or compressed with some ratios. So which is the main function of a source encoding technique. And In the source decoding technique, it is to be unzipped or it is to be decompressed. So that is the main objective of source decoding. And in channels, either in encoding we do protection. We protect our information such that the unwanted people doesn't harm them, right? Or the secured issues, as I said in earlier in the class, this information theory will be lying as a fundamental for securities in terms of network securities. So that protection is being provided by cyclic redundancy check or CRC. And if any error occurs, so that error has to be rectified. For that, we need to verify CRC, which is the function of channel decoding. I think most probably nowadays we are having an advanced technique called OTPs. Has anyone heard about OTP? One-time passwords. When you do a transaction between in your mobile phones or in your internets or through your banks, you will get a one-time password in your mobile if you are doing any purchases using UPI or NEFT. Right? Have you anybody heard about OTPs? Anybody can give me?
Yes, sir. Yes, sir. Yes, sir.
Familiar? Oh, okay.
Yes, sir.
Familiar with OTPs?
Yes,
Okay.
sir.
The server will generate an OTP of appropriate bank. They will send it to the appropriate user. So that user, when they put it in the appropriate slots, you will be verified. So that is the major function of your CRC. Okay, that is an best example. So coming on to the example of VCD and DVD. Okay, so can everyone able to see this orange color box? What I had written in it? Orange color box, orange color block.
It's a movie. Movie.
You're able to visualize what it is being written, right? Because same color is matching. I'm asking. Okay, movie. So movie which is being recorded are being done MPEG encoding. Anybody is familiar with the MPEG? Any expansions? If you don't know, also no issues. I'll let you know what it is. So that is a function of source encoding. Then we have an RS encoder, channel function of channel encoding. Then the channel is CD or a DVD. Then decoding it back by RS decoding. Then we have an MPEG decoder. And what is our user? User is a television operator or a TV. Television is your device. Okay. So movie is your data, TV is your user. So what is this RS stands for is most of your doubts is that read Solomon codes. So it is a special type of encoding as I said about OTPs. Okay, those all are high encrypted systems, OTPs. So whereas this are very low, basically fundamental coding techniques. And coming to the expansion of MPEG, moving pictures experts group. So they are moving pictures experts group. So they had evaluated this type of scheming for exclusively for video. So in video, can anyone give me what would be present inside in video? What would be present inside a video? Any type of signals that you are familiar? I don't want to call each and everyone by asking some of the questions. I don't like that. If you know, you can give me. Hemant Kumar is asking to join. Whether he's in our class? I don't think so.
No, sir. It's not our class.
No, Hemant. So I can skip him. I'll deny him. Okay. Or they want to check whether how the class is going on. Somebody, maybe sure. Okay. Can anyone say me what an video will consist of? Okay, rather than asking that, I'll ask you, uh, what type of signals are present in a television? Any ideas? I think in a television we have main use of television is what? Visualization. So where we have video signal, and in television we have another part called audio signal. We have speakers which gives us audio information. So this audio information is an example of your speech. Again and again, somebody is coming. Again, Hemant Kumar is coming. I'm not sure he's not there.
Not there, sir. Dabba, not there, sir.
I will not. Okay, it's not there. I'll deny. Because you may not get those information who is asking for a request, right? You may not get. Yeah. Okay. Is this example VCD and DVD visible?
Yes, sir. Yes, sir. Yes, sir.
Okay. So in television we can see. In television we can see whatever we want to watch, and whatever at that particular time, whatever is being relayed in speakers. So a television signal will have both audio signal and video signal. So how do you get this audio? Is that by speech processing, by the help of either PCM, PPM, PWM. Any of these modulation schemes can be used for speech processing. And when coming to video signals are a sequence of images per frame. So that is being concised together and given as video. So we have so many algorithms or so many systems for doing video processing. So those intact with this MPEG will give us an appropriate compression and decompression algorithms. Okay. So moving on to the next example. Next example, I had shown you this, right? Someone had identified it accurately, cellular phones or mobile phones. So here the data itself is your cellular phone and the user itself is your cellular phone. So we'll be using in olden days, not nowadays. So these are for example, I think so. This comes under your 2G technology, second generation mobile systems, where only speech was your main primary information. We had used only speech. I think most probably everyone would agree with that. So we'll be using speech encoding schemes, as I said earlier, and will be encoded by some coding techniques of CC, which we call it as convolutional codes. Then those codes will be sent to us usually to channel, and decoding will be done with the appropriate convolution code, a decoder, and appropriate decoding speech system. And this technology which used mobile phones is your GSM or CDMA. I think probably right from 15 to 20 years back, you would have heard about the 500 rupees Reliance phone. I think you may not be familiar. Your parents might be familiar. During 2001, 2, 3, 4, 5, 6, or 7, even 8, 9, 10, 2008, 9, 10 also, there was a familiar phone in the market released by Reliance Groups. They used to call it as 501, 501. The meaning is that the brand of name was given 501 such that the price of the mobile phone was 501. If you give 501 rupees to the vendor or to the shopkeeper, he will give you a mobile phone unlimited talk time for the year was the scheme being introduced. So that used only GSM technology or your CDMA technology for communicating to systems or to devices. So next example, someone had found out the answer correctly. Router. So router follows this wireless LAN principle, which was given by IEEE 802.11b, which we called as wireless local area networking. So this IEEE stands for Institution for Electrical and Electronics Engineering. They are a forum who approve all these standards worldwide. So whatever the standards are being introduced newly for exclusively for electrical and electronics, they have to approve them and they will give a label to them, depending upon the technology and size and how many vendors or markets it's being given. Okay, what is its need? So this uses zipping and unzipping in the encoding techniques, source encoding and source decoding respectively, and it uses convolutional codes at your encoder and decoder and remains the same. Only the coding and encoding in the format of zip and unzip. So what does this? Okay, is there any doubts till this slides that I had shown you in the relevant examples or in any of the introduction part?
Sir, what is CC, sir?
These all are introduction. Convolutional code.
What is convolutional code, sir?
It is a type of coding scheme that we will detailedly study in Unit 5.
Okay, sir.
Yes, in Unit 5. What is convolutional codes, how it works, how it is used for parity checking or parity generation. I think in a digital system design, you would have studied parity checker generator, right?
Yes, sir.
Have you heard at least
Yes, sir.
parity checker generator? Yeah. This parity checker and generator will give us how many bits of symbols or messages are being odd or even. If I use an odd parity, if odd is the sequence of symbols of 1, it will show me 0. If it is even, it will show me 1. So like that, we have a special convolutional code which uses modulo 2 addition. So that we'll see in detail how does this CC operates. We have a full entire chapter on convolution codes. Need not worry about CC codes. So that's what this coding is. Cyclic codes and convolutional codes in Unit 4 and 5. We'll be seeing in detail.
Okay,
So
sir.
what is our role and what we are going to learn is that only about specifically about this codings in Unit 4 and 5. And Unit 1 to 3, what is the format for that? What are the procedure or rules and regulations laid? How do we utilize it for efficient communication? That we are going to see in Unit 1 to 3. Detailedly we'll see. Still I haven't started those topics. Just it's an introduction section. So any doubts till this? So this Shannon theory, which was being formulated by Sir Claude Shannon, contains three different important points. One is how do I measure the information in terms of bits? How does source coding theory works out? How does channel coding theory works out? Okay. So he had given some three source coding theorems. Okay, so the first source coding theorem states that for an reliable information, we need to generate some sources which is having an on an average of h of x bits for an outcome if x is our source. In order to have a reliable communication, the information generated by some user, I call that user as x, we need to have an average of all of this, either more than or less than them. Then only we can have any more information. So I'll give you this with a relevant example. If, for example, if I'm having 100 bits to be transmitted, and the coding theorem or the coder should have an efficiency of more than 100 symbols such that information will be reliably transferred. More realistic example I'll give you is that if I have what to call if a person is having 100 rupees, he is in Delhi. We'll assume that two persons, one person in Delhi, one person in Hyderabad. The Delhi person is your source. He's having 100 rupees and he wants to transfer to his friend in Hyderabad. At Hyderabad, he wants to transfer 100 rupees. So what he has to do? He has to rely on somebody such that he can take 100 rupees to him and reach. So he can use either PayPal or PhonePe or whatever modes of transformation he want to do, he can rely on. So for example, if I say that, for example, if a system of PayPal for transferring of 100 rupees, he's taking 20 rupees with him and giving only 80 rupees, whether you will rely on him for transformation? Obviously, I won't rely on him. I won't rely on PayPal if he is taking 20 rupees out of 100. If another vendor, if he is using another vendor, for example, take PhonePe, he is taking 50 rupees out of the transaction. So Delhi person is sending 100 rupees to reach to Hyderabad. In between, this PhonePe is taking 50 rupees out of that. So the remaining only 50 reaches the person in Hyderabad. So this will not be reliable. So what it should have is that whoever sends 100 rupees, he should add on that, or he should send the same to the corresponding user or the corresponding person in Hyderabad. If Delhi person is sending 100 rupees to Hyderabad, the Hyderabad person should also receive 100 rupees. He should not receive less than that. So this was his first what do you call first theory on source coding. So the information that is being transferred should be reliable on some aspects. So that is what is first source coding theorem. So that in terms of our information is what is being given as source coding theorems. Shannon's first source coding theorem. Okay, so that X can be anything. It could be a Delhi person, or it could be a user 1 or user 2 or user 3 or any random sources. Okay. And all the events that are being generated, all the events means when we pick one device or when I want to transfer one information to another, so that is an event. If I'm sending 100 rupees from Delhi to Hyderabad, it is an event. If I'm giving an information from one place to another place, that is an event. So all the events are probabilistic in nature. So this is what he has proved it and showed it. So for that, the average of that, all the events is taken as h of x, which is summation of all the probabilities, with a limit till maximum number of events. For example, if I have 10 events, so 0 to 10. If I have 15 events, 0 to 15. So that x is variable. So 0, p of 0, p of 1, p of 2, and goes on. So this measurement of Shannon's information in terms of h of x, which is a summation of all this or an average of all this, is called as an entropy function, which measures the amount of information transmitted in number of bits. So the measurement of information in terms of number of bits can be only done by measuring its summation of all the probabilities of occurrences to its maximum possible limit, so which we call it as entropy function. For example, I'll show in a realistic example that we had done in childhood days, or you would have been doing during this COVID pandemics, using a die. For example, I have a die, I toss a die. The outcome is that a die is a cube, it will have only 6 faces. So the probability of occurring would be either I will get 1 or 2 or 3 or 4 or 5 or 6 at a time. So each occurs at a probability of 1 by 6. Why? Because at a time when you toss a die, we'll be measuring only one event, but the number of outcomes could be 6. So there are 6 outcomes, and at a time I can get only one output, or I can measure only one value. So probability is 1 by 6. So how do I calculate the entropy for this? So use the formula x is equal to varies from 0 to, we don't have 0, sorry for that, since it starts from 1. So 1 to 6 probabilities, so p of I log of to the base 2 p of I, so which when I substitute appropriately, I'll be getting 1 by 6 log to the base 2 of 1 by 6. So where I do summation of all the things, right? If I write 1 by 6 of probability of 1 plus 1 by 6 probability of 2, 1 by 6 probability of 3 plus 1 by 6 probability of 4 plus 1 by 6 probability of 5 plus 1 by 6 probability of 6. So when I sum all these things, I'll be getting 1 by 6 probability of 1 by 6. So when I do all these things, I'll be getting log of 6, so which is equivalent to 2.585 bits. So in this example, the entropy function can give us 2.585 bits for this tossing a die. Okay, so this is a good example of tossing a die. So any doubts in this? I think just a moment.
No, sir.
For every session, I'll give you some 5 to 10 minutes for discussion. You can have a discussion with me or with your friends also during our class, such that any confusions or any issues that can be sorted out easily. For every session, I'll give you. So if you have any doubts, you can ask till this.